Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And students, today we are going to explore a very interesting topic from which you usually get two or in every 2 or 3 years you get a question from this topic or the next topic that we are going to analyze in this pursuit. And make sure you also cover error analysis after this topic because sometimes you get a combination of this topic and error analysis. Yes, today we are going to get started with Vernier Calipers. And students who know me well and good, if not, I am Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from University of Colorado Boulder, one of the top ranking American university in electrical engineering, and I am also an IITian who completed my BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I filed 25 patent applications in India and abroad. And that being said, students, do download our do download the Telegram app if you don't have one, and get on to our Telegram channel. All you need to do is click on to that link available in the description box below. Else just type in JEE_English to find us on Telegram. So this is the one-stop place where you would get all the updates happening on or that is being conducted by JEE English channel lecturers. So be it any special classes or be it any Unacademy learning app sessions or any YouTube sessions, and also to get daily updates on what is going to happen on JEE English, you can get it from this channel. So do get onto this channel. Just check out this channel, click on to that link available in the description box below. And students, if you haven't yet completed the previous lectures on Unacademy learning app, do check them out. We conducted many sessions. I personally have finished anywhere around the entire current electricity. We are right now onto the quizzes. We also covered electrical instrumentation in one shot and color coding of resistors, which is like the topic where you typically get your questions in your IIT JEE Mains and also in your IIT JEE Advanced. And that being said, students, to attend many such special classes, and these are free of cost special classes, so do download the Unacademy learning app to download to attend these special classes. All you need to do is type in Unacademy on your your Google Play Store and App Store, and the first link is going to be your Unacademy learning app, and you will click install on it to download it. And also, plus students, make sure you have this because this is going to keep you updated with all the things that you need for your JEE preparation. And as well as students who are attending special classes, make sure you install this app because you will get all the live updates and timely notifications on special classes happening on Unacademy learning app. And that being said, we have an awesome package, or you can say that we are an awesome platform for your JEE preparation, which comes with live quizzes, live test series, and you can learn from your favorite educator. And it's only one subscription, and you get unlimited access during that period. And guys, it's the state-of-the-art technology that is required for your JEE preparation, and you get to experience that exam environment. And remember, students, you have to attend the lectures, but it's also about giving that tests regularly so that you can excel in your exam and you get accustomed to the kind of the practice that you'll be doing on this platform. And how do you avail this platform? All you need to do is click on that extension and choose the first icon, and then be sure to choose IIT JEE as your goal. And guys, that's all you need to do, and then you will avail the subscription. And that being said, right now the prices are low, the prices are slashed. Make sure you get it today itself, because it's from tomorrow the prices are going to be hiked. So right now the prices for anywhere around 24 month subscription is near about 1,500 per month. And guys, if you apply Murli live coupon, you will get a 10% additional discount on this purchase. So don't forget to apply the Murli Live coupon. And right now the prices are low, guys, and for a 12-month subscription it's going to be 2,500 per month. Nearly 2,500 per month, and you can apply this Murli Live coupon to get 10% instant discount. So don't forget to apply the Murli Live coupon, and don't forget to purchase the subscription today, because there is going to be an hike from tomorrow, that is from 10th of September. So make sure you avail it early. Hi Shivam, hi, a very good evening. And that being said, guys, only one day left to avail the subscription. So make sure you get it early, guys, so that you don't have to pay those extra bucks, especially 11th class students. Make sure you're getting it early because you can see you are going to choose maybe like your 2-year subscription if you're in 11th, 9th or 10th class. and or if you are going to go for 2 years preparation, it's typically a 2-year long journey. So you know that it's like 32,400 right now after applying Murli live coupon, but like right from tomorrow it's going to be like 50,400. So make sure you get it early, guys, so that you don't want to pay that extra 18,000 bucks. So make sure you avail it early, and this price is after even applying the coupon. So hurry up, guys, get it early, get the subscription today, so that you can get that 10% awesome discount on your, not only the 10% awesome discount, you're going to get the 10% awesome discount, but make sure you get it today so that you can avail it at the low prices. So that being said, guys, an experiment is a question which science poses to the nature, and a measurement is the recording of the nature's answer. And today we are going to talk about the length measurement, and we are going to record some precise a response from the nature. That's what today's lecture is all about. And let's get into the lecture. So how do we used to measure length until now? We were using meter scale, and these meter scales are limited by precision, and they cannot handle more than 1 centimeter or 0.1 centimeter depending upon the kind of the scale you have. So the least count is typically only 1 centimeter. In case of your meter scale, you can see there are many divisions over here, but this is like in centimeters. So one division is only going to be 1 centimeter, or in some cases it can be 0.1 centimeter. So what is the disadvantage, and really can meter scale cater all our needs? Probably not. So let's say I have to design a beaker, like a lab instrument, where I need precise measurement of things, and once I've designed this beaker, I need to run some quality checks, or I need to verify whether this beaker is aptly designed. How do I do that for any lab instrument in that case? So meter scale is not accurate, even though it can measure up to 0.1 centimeters. In some cases you can't accurately measure even up to that 0.1 centimeter. It's a huge limitation of that meter scale. And even let's say you want to, you have designed something, some engineering stuff where you have, this, hollow cylinders, or let's say you have some spherical ball bearings, etc. You can't really use meter scale to measure the diameter. Even the 0.1, still you can't measure it really up to that 0.1 centimeters, or even in that case to 1 centimeter. So 1 centimeter in this case is going to create a lot of inaccuracy. Do remember, guys, let's say if I have to measure the internal diameter, it's not possible. You're going to place that scale on top of this, hollow cylinder, but still it's not accurate, right? And you need to make sure things are accurate while designing, industrial stuff or some machines, because you don't want your machine not to work, or you don't want to redesign the structures while manufacturing things. So again, meter scale is not applicable. You can't really measure with meter scale. So it's a big no when it comes to engineering stuff. And what about, measuring diameters of grooves or the depth of grooves? And let's say even in the earlier case, we had to design a beaker. In the beaker we had two things. One was the diameter, and the other one was the depth of the beaker. Both was not possible because your meter scale is not going to give you any accurate results, because they are going to be imprecise. So the measurement, so least count is low. Not only that instrument is not suitable, guys, and even for some machines that you're designing, many times you need to design some grooves like this. You can't really use meter scale. You need something that is going to be more accurate, but also designed in such a way that you can measure many things using that one device. So that is what we are going to discuss today. It's going to be about Vernier Calipers. Yes, your Vernier Calipers can do all of those things that we discussed. You can conduct better research, you can design better mechanical structures, you can design better machines, and you can also conduct quality checks. And the other advantage is the least count of your meter scale is going to be only 0.1 centimeter, or in some cases 1 centimeter, whereas at minimum your Vernier calipers can measure in mm. So in up to millimeter, 0.1 millimeter accuracy is what you can measure. That means you can design better stuffs for your research, for your machine design, or even to conduct quality checks. So that being said, Vernier calipers is a very useful measuring instrument, and where all you can use it, you can measure typically the length, breadth and height with more accuracy. So when we're talking about meter scale, we are probably only going to use it in a tailor shop, or maybe in a steel shop, where accuracy don't matter much. But when we are talking about Vernier Calipers, it's a real engineering thing, guys. Like, it's a real engineering thing. And good evening, Renu. Very good evening, guys. And do like the video and do share the video, students. Do share the video. Do share this channel. And guys, it's a free of cost initiative by Unacademy, where you get all your lectures from basics until the depth for your JEE preparation. So do share this channel and this video on your Facebook, WhatsApp, Twitter, wherever you are, so that people can get access to this amazing lectures. And what about depth? Yes, your Vernier calipers can also measure the depth of the beaker, the diameter, be it the inner diameter or an outer diameter of a structure, you can measure using a Vernier calipers. Okay, so generally with a good precision, that's going to be like 0.1 mm, and it differs, guys. So in your syllabus you generally have anywhere around 0.1 or 0.01 mm, but Vernier calipers can measure up to generally up to 4th decimal place, 5th decimal place in some cases, but when we are talking about your IIT JEE syllabus, you're going to talk about only like the 2nd decimal place of centimeters or 1st decimal place of millimeters. So do remember this. So your syllabus typically has only this much, but anyway, the concept is the same. Nothing is going to change. And that being said, how is really a Vernier calipers made, and how is it so efficient? So then just you have separate components for measuring things separately. For an example, let's say I have to measure diameter of a cylindrical or a spherical object. I'm going to make use of something known as jaws of the Vernier calipers. And using that, you will be able to measure the diameter of let's say it's basically for outer diameter. You got that point. It's going to be for outer diameter or any length. Okay, outer diameter, or you can measure length, etc. using this lower jaws, and there will be a jaws on the top which you are going to make use of to measure the internal diameter. So things are very accurate. And also for depth, you have a strip, and you can see this strip over here. This is going to be known as like your depth rod, or this strip would keep on extending. So how does this work? It has like 2 scales. So why do you get the same better accuracy using the same scale? So you have 2 scales over here. One is going to be your Vernier scale, and the other one is going to be your main scale. Right, your main scale is probably going to only have as much accuracy as you're expecting in your typical meter scale, or let's say a more accurate meter scale, but your Vernier scale is the one that is going to determine everything. So it's a very interesting tech, and that being said, most of the times it is designed such that the Vernier scale divisions are like typically of the lesser let's say lesser value, or lesser, that means more accurate than your main scale. So typically in this case, maybe your Vernier scale is like something like 0.0 not really 0.01 mm. So if it's going to be 0.1 mm, this is going to be 1 mm. Okay, so if this is like 0.1 centimeters, so your this scale can only measure like 1 centimeter. So things like this are made sure to design, not exactly like this. We'll understand how this works. So, but they have near about the same kind of reading, but we are going to do something interesting. That is what it's basically not 0.1 mm or like 0.1 centimeters. It's your Vernier scale is only capable of measuring 0.9 centimeters. If this can measure, 0.09 centimeters. If this can measure 0.1 centimeters. So, but the least count of Vernier scale is typically not determined this way. First of all, let's start understanding what is this Vernier scale and how do we do this thing. So, for an example, let's say this is in centimeters, okay, and this is your Vernier scale, okay. And what you're going to do is you're going to design the scale such that the 10 readings, okay, the 10 readings of this Vernier scale, if you see, this is the 10th reading, is going to coincide with the 9th reading. Okay, the least possible 9th reading of this is just an example. It can be designed anyway. So this is going to be the 9th reading. That means your Vernier scale is measuring at far better accuracy, given you are going to just measure using Vernier scale, but you're not going to do that. Let's understand what we are going to do. We can measure even with more accuracy. How do we do that? So first of all, let's understand if this was let's say 1 centimeter, and your 10 divisions of Vernier scale equally divided, can measure up to like the 9th reading. So the 9th reading is going to be the 9th reading of main scale. So your main scale is one thing and the other one is your Vernier scale. Let's say your main scale's 9th reading is going to be 0.9, as you can see over here. It's going to be 0.9 centimeters, right? And how about I'm saying that your 10th division, okay, this is not centimeter, this is in centimeters, but this is not centimeter. So let's say your 10th division is coinciding with the 9th, but they are all equally divided, right? All this is like there is, you know, only one division between this, and there is one division between over here. So it's only one division, one equal division, okay? So it's 1D, 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 1D distance between each divisions. So that means your Vernier scale. So try to understand the concept. You don't want to miss out the concept in this topic, because your JEE advanced problems are mostly very tricky based on these concepts, okay? And your Vernier scale is going to have 10 divisions for the 9 readings, okay? So these two are equal. So what is one Vernier scale divisions reading, or the value of one Vernier scale division? That is going to be 0.9 divided by 10. How much is that? 0.09 centimeters. Okay, that means your Vernier scale can measure up to 0.09 centimeters, right? Whereas your main scale can only measure 0.1 centimeters, whereas your Vernier scales, each division is 0.09 centimeters. But that's not how we are going to measure it. Let's understand how this works. So for any given Vernier calipers, if they say n division, so it is not typically going to be 10 in your exams, or when you're going to even deal with some of the Vernier caliper instruments. Depending upon the applications, this main scale, they are going to say this main scale is having n divisions, and this Vernier scale is having m divisions, and this n divisions of Vernier scale coincides with the m divisions of the main scale, okay? So n divisions of the Vernier scale is going to coincide with the m divisions of the main scale. So that means we can say that MSD is nothing but main scale division, okay? MSD is nothing but main scale division. We just saw how to derive the value of Vernier scale reading or the Vernier scale division. So this is main scale division, okay? That means we can write it down as NVST is equal to MVST. Simple math, guys. So it's a simple math. So we will be just writing it down as NVST is equal to MVST. So let's understand something more interesting. So 1 VSD is going to be m divided by n MSD. So in that case, in our example, it was 9 by 10. So we got 0.1 centimeters. So we got something like 0.09 centimeters, right? Hi Kaushik, hi Vinayan. Yeah, please do ask your doubt. Yes, I hope if your doubt is regarding Vernier caliper, it would be cleared by the end of this chapter. Don't worry about it. You can ask your doubt. So let's move on until then. So this being said, what is that least a measurement that you can measure on this Vernier scale? If you notice this gap over here, how much is this gap? This gap is something that we can measure, right? Like, how do we do that? We'll understand it once we start understanding this. So this is going to be the least possible measurement on this scale. So if this is the least possible measurement, this is something that you can measure on your Vernier calipers, right? So this is something that you can measure on your Vernier calipers. I mean, what is the difference between this Vernier scale and main scale? Nothing much. Really, right? So this can measure 0.09 centimeters, whereas this can measure 0.1 centimeters. But what we are going to do is we are going to make use of this gap to really assess things very precisely and accurately. Okay, let's understand this thing. So talking about your what is going to be the least count or the least possible measurement, that is going to be actually not this gap. Basically, this is 10 main scale division minus 10 Vernier scale divisions. So it's going to be the same thing, but that's going to be 10 times the least count. But the least possible measurement could be something like 1 main scale division minus 1 vernier scale division. Okay, little bit of engineering here and there. It's not, a very straightforward calibration. What they have done is they have taken, like a vernier scale and a main scale. So you put an object between those jaws that you saw, and what they would do is between those jaws they would be able to exactly assess how what is that extra reading that is going to be. You will understand it as we move forward. So the least count is going to be 1 main scale division minus 1 vernier scale division. Okay. And so this can also be written as, so we know that mn into vernier scale division is equal to m into main scale division. Okay, so if there are m divisions, the n divisions on your vernier scale that coincides with the m divisions on the main scale, then this can be written this way. So that means your vernier scale division can be written as m by n main scale division. And similarly, a main scale division can be written as n by m vernier scale division. So that way you can find out least count even given the value of either main scale division. So what we are saying by main scale division and vernier scale division. So main scale division, vernier scale division is that we are talking about the value of that one mark, or the value of that one point on that scale that it can measure, right? The value of that one mark or that one thing that it can measure on this. Similarly, even on this, it's going to be value of one one calibration mark or something like that. Okay, so this is just a mathematical manipulation, but what you have to know is the least count is nothing but not direct vernier scale reading. Vernier scale reading is different. Vernier scale reading is not going to be the accuracy of a vernier calipers, but rather least count is going to be the accuracy of your vernier calipers, which is going to be the difference between 1 main scale division and 1 vernier scale division. Okay. So that means in this case, what is the least count? That is going to be something like, let's say this are in centimeters, and you very well right now know how much is this. So I'm going to say least count is equal to 1 MSD minus 1 VSD. So that is like, 0.1 centimeters for your main scale. And how about your vernier scale? 0.09 centimeters. So what is the least count? Your least count is going to be 0.01 centimeters. Very accurate, right? Let's understand how this works. Okay, so but for now, understand this is how you assess given any like a main scale division or vernier scale division. If they say n number of divisions on vernier scale is coinciding with the m number of divisions on main scale, you can either do this 1 MSD minus VSD, or you can do 1 minus m by n into MSD, or n by m minus 1 into VSD. Yeah, very good, Vinayan. So yes, that's it guys, and let's get started with the JEE Advanced problems. So have a look at the kind of problems that you get. This is JEE Advanced problem, and you can literally let me know if you find any difficulty in this problem. So this was literally a problem, and what is given to you? It is given that you have n divisions on the main scale of the vernier calipers that coincides with the n plus 1 divisions on its vernier scale. Students, get started on this problem. It's a JEE Advanced problem, so make sure you get it correct. And if each division on the main scale is of A units, determine the least count of the instrument. Okay, they can say least count or the most precise value, or up to the decimal place what it can measure, or the least possible value that can be measured by the instrument. Okay, different kind of terminologies can be used. So what do you think should be the answer, guys? So let's get started on this. So let's do a thing. Just for now, what I'm going to do is I'm going to move through equation by equation, but you can apply the expression and get the answer directly. So you know that n plus 1 BSD is going to coincide with the nth main scale division, right? That is it. So how much is your one Vernier scale? So given to you is A units. Okay, each division is, so MSD is given to you. So very simple problem, right? This is like a 2 minutes problem that you could have done. MSD is equal to A units. And what is your VSD? VSD is going to be A into, I'm directly writing it down as A, MSD is equal to A units, A into N divided by N plus 1. What is your least count? You could have done 1 minus N by M, or we can even do this. Okay, 1, so okay, let's do it. I told you we'll just move. So why am I talking about this using MSD minus VSD? Because that is the way to go about it, guys. Okay, so what if your Vernier scale division was larger than your main scale division? Still you must be able to find out the least value that this instrument can measure. Okay, so your main scale division is going to be A, and your Vernier scale division is A into N divided by N plus 1. How much is this? This is nothing but 1 divided by, so A divided by N plus 1. Right, that is it, right? I hope everyone got this. It's pretty easy, guys. Right, A divided by N plus 1. Your N plus 1 gets carried over here, N gets cancelled, only 1 would remain. So your least count is going to be just A divided by N plus 1. Pretty easy, simple, scoring, no efforts. Alright, let's move on to another JEE Advanced question. The 2 JEE Advanced questions, and this is also quite easy, guys. Get started on this, students, get started on this. A Vernier Calipers has a 1 millimeter mark. Thank you, Vinayan. Thank you so much. So yes, get started on this, Vinayan. Get started on this problem, students. So a Vernier Calipers has 1 millimeter mark on the main scale, and it has 20 equal divisions on the Vernier scale that matches with 16 main scale divisions. So what should be the least count of this apparatus P or this Vernier Calipers P? Okay, so you can move by the expression, or let's again do a thing. So get started on this. Until then, you have the Vernier Calipers has 1 millimeter mark, guys, on the main scale. Okay, all you need to know is this thing. So 1 MSD is, you don't have to do everything while you're calculating it. You should be faster than me, guys. And it has 20 divisions on the Vernier scale that match with the 16 divisions. Okay, so if I'm going to write N VSD is equal to M MSD, what is the value of N over here? 20 VSD, and we know what is MSD, that is going to be 16 mm. 16 into 1, that is 16 mm. And how much is 1 VSD? 1 VSD is simply 16 divided by 20. Let's see. Try it again. One more thing, guys. You could have directly intuited the answer. Okay, so one thing is it should be less than 1 mm, that because main scale divisions reading is 1 mm. And the other thing you have to notice is 20 divisions on Vernier scale is matching with 16 main scale divisions. Of course, it has to be less than 1 mm. And the next thing you have to notice is what is the kind of ratio that you have over here. Think about it. It's going to be like something like it should be like in 2s or something like that. Try to directly try to directly guess it, but also work it out. If you're not getting at the moment, that is fine. So that's going to be 4 by 5 mm. Right, this is the value of 1 VSD. And what is your least count? Least count is nothing but 1 MSD minus 1 VSD. These are some of the simplest questions that you would come across, guys. You don't want to miss these questions, okay? You have to, typically crack these questions very easily. So that's going to be 1 by 5 mm. How much is 1 by 5 mm, guys? Don't directly take 1 by 10. Don't go by 1 by 10. That's why we never discussed 1 by 10, guys. Okay. That is something that you would see in your lab, of course. That is true. But don't directly go by 1 by 10. It's 1 by 5 of an mm. And 1 by 5 of an mm is nothing but 0.2 mm. Right? Simple. Let's move on to the next question then. Again, a JEE Mains question. This is actually very interesting, guys. Actually, I've noticed that your JEE Advanced has, lesser, tougher questions than in your JEE Mains when it comes to Vernier Calipers or your screw gauge. So in an experiment, the angles are required to be measured using an instrument. And it says that, so this is like a Vernier scale, they are saying that 29 divisions of the main scale exactly coincide with the 30 divisions of the Vernier scale. If the smallest division of the main scale is, half a degree, 0.5 degree, then what is 1 degree is equal to 60 minutes. But this information was not given to you, so carefully work around this. So then the least count of the instrument is how much? Alright, let's get started then. So 29 divisions coincide with 30 divisions. So this time I'm directly going to write down as 1 minus m by n into, so this is your least count expression, into MSD. Depends upon what kind of thing is given to you. So it's 0.5 degree, 1 minus of 29 by 30. Is that what you have? 29 divisions on your main scale is coinciding with the 30 divisions on the Vernier scale. Notice it carefully, guys. Notice this thing carefully. That is it. Okay. And what else is given tricky to you? Of course, the unit conversion. So 0.5 degree. So this is only half a degree. So still in degrees, we need to convert it into minutes once we get the answer, because your answer is given in minutes and degrees. And you of course know that if your main scale can measure 0.5 degrees, your least count has to be less than that. Okay. And how much is this? 1 by 30, is that what it is? Into 2, how much is that? 1 by 60 degrees. 1 by 60 degrees is equal to how much? 1 minute. Right? Really simple. Okay, this is something that you may have to remember. Degree to actually I've noticed 2 questions on your JEE Mains paper where they haven't given degree to minute conversion, but your answers were asked in degree and minutes. So it's of course not 1 degree, that it's not half a degree, that you need to figure out whether it is 1 minute or half a degree. So the divisor is going to be 1 by 30. Since it's 29 and 30, that was 16 and 20. There the divisor was 4 by 5. I mean, like the multiplicand was 4 by 5, and then you could have found out into 1 mm. And here it's going to be 1 by 30 into 1 by 2. So it should be 1 by 60 degrees, which is going to be 1 minute. Quite simple. So let's move on to the next question then. So like 1 mm of a main scale of Vernier calipers is divided into, okay, this is actually pretty interesting. Okay, so now what they are asking you, the Vernier scale has how many divisions is what they are asking you. So what about your Vernier scale having the number of divisions? So 1 mm of main scale of a Vernier calipers is divided into, main scale is what they are talking about, is divided into 10 divisions. If the least count is 0.005 mm, then your Vernier scale has how many divisions is what they're asking you. Quite simple, guys. So just in this case, they haven't spoke explicitly about your Vernier calipers having more number of divisions, or more number of divisions coinciding with the lesser number of divisions of Vernier scale. So let's see how to do this. This is going to be 1 minus n by m, m by n, or whatever it is. Okay, which should be the numerator and which should be the denominator. So it is going to be 1 divided by m by n into MSD is equal to your least count, right? And so what is your least count in this case? 0.05 mm. Hi Joey, hi. So this is 0.05 mm, and is this given in mm? Yes, do verify it. Whether if it is given in centimeter or mm, you need to make sure you verify these things, guys. Okay. Sometimes your Vernier scale can be far more accurate than your main scale. So make sure you have those things. And this is divided into 10 divisions. That's what they told you. But I guess, it is fine. So this is going to be m divided by 10 divided by n. N is what you have to find out. Divided by n. Let's move this over here. So this is going to be something like 0.01 minus 5, and that's 1000. Okay, sorry. So this is going to be something like this, I guess. Yes. To an extent, it is very important in the sense like you get very easy questions. So this is the standard thing, students. So you get very easy questions in these kind of topics, and you don't want to miss out anything in these kind of topics. It's typically that kind of thing. So this is very important, yes, because you can easily score without spending much time. You saw your JEE advanced problems. It was very easy, and you could have easily scored in it. And okay, 1 minus 0.05, that is going to be 9.5. What is this? 1000. Let's keep this 1005. You're going to get something like 9555. Sorry, I'm really sorry, guys. Okay, so I think this is actually a little complicated than I expected. Okay, so easier way of doing it. I think we did a mistake. So the mistake is, it was actually a confuse me challenge problem. So 1 mm of main scale is divided into 10 divisions, which means 1 main scale division is equal to 0.1 mm, right? And what is typically supposed to be a 1 Vernier scale division? 1 Vernier scale division is equal to least count, 1 main scale division minus least count. One main scale division minus 1 Vernier scale division is equal to least count, and your Vernier scale division is equal to main scale division minus least count. And this is going to be just 0.1 mm. We don't have to work very hard, and I think there is an issue with this question. Anyway, let's check it out. What is the issue? The Vernier scale division has how many divisions? 1 mm of main scale is division. The least count is 0.05. So we can find it out. So 1. Okay. So yes, this is going to be 0. Okay, we are doing it correct, I guess. 0.05. That is going to be 0.995. Is that what it is? Are we correct? 0.001. No, you're not correct. So this should be 0.095. So let's do this. 0.09501, and you get 0.01. Okay. Is how much is your Vernier scale is able to measure. And how is that possible? That is only possible if n times of 0.095 is equal to 10 into, okay, it's just 1 mm. This point, 10 into, it is m is 10 divisions, but the 10 into 1 is nothing but 1 itself. Pretty much everything, guys, everything, like, you know. So n is equal to 1 divided by 0.095. There is no such options matching it. I guess we would have to not do this question then. So it should be, yeah, I think we have done it correct. Okay, one Vernier skill. The important chapter includes everything, guys, everything, but try to cover, you know, simple topics first so that you have a lot of leverage in your exam. I guess we did everything correct, and it's going to be 0.095, and I think this should be, yes, Vinay, pretty much every chapter, guys, pretty much every chapter. So this should be your answer, but there is no answer in the option, so it's fine. Let's move on to the next question then. Yes, coming to your important chapters, it's going to be everything, guys. Try to cover easy chapters like this, because you typically get 1 or 2 questions from you know, units and measurements or units and dimensions, and they are going to be super easy. And your mechanics, of course, and electrostatics, current and electricity, magnetism. These are, like, you know, 5 or 6 things that you need to do, but don't miss out optics. Also for your JEE Mains, nuclear physics is very important. You get anywhere 10% is around nuclear physics. Okay, later on you can check out the syllabus video. And 19 divisions on the main scale of a Vernier calipers coincide with the 20 divisions on the Vernier scale. If each division on the main scale is 1 mm, determine the least count of the instrument. Okay, so I guess this one does not have any confusion. This is going to be 1 minus you know, m by n. Okay, is equal to least count, and then it's 19 by 20. 19 divisions on the main scale coincide with the 20 divisions. Okay, so it's 1 by 20 into your main scale division. What is the value of each main scale division? Each division on the main scale is 1 mm, so that is going to be 0.05. Is that what we are going to have? Yes, 0.05 mm, right? So it should be C. Check it out. There is also centimeter, there is also mm, so don't make any you know, mistakes in the units. So yes, let's come to the most interesting part. How do you read on your Vernier calipers, and how do you really know the things that have been told to your lab is correct, and etc. So first of all, let's understand this thing. Let's assume we have a rod that has been kept. So how do you typically do things, like how we saw, you know, in our that, you know, in that case where we had, you know, like that sphere between those jaws. So now think about it. A rod has been placed, and you know, these are between the jaws. And so you first of all understand, just like how you see in your scale, this rod is greater than this in this case is, you know, like 10 divisions. Let's assume this is in centimeter. That means this is, like, you know, 1.1 centimeter. Is that what it is? 1.2 centimeters. So you know your reading is greater than 1.2 centimeters. But how to assess this point? Very important, students. Very important means very important. Okay, you literally add a couple of JEE advanced questions, which was basically based on this concept. It is a concept, guys. There is nothing to memorize in this. Even the earlier one was a concept, like finding out the least count was also a concept. This is also a concept. Okay, now let's understand. Okay, I told you the least measurement on that, you know, through some sort of technique is going to be, you know, 1 MSD minus 1 LSD. 1 VSD. So 1 main scale division minus 1 Vernier scale division. Now in this case, you need to measure this length. You very well understood it is greater than this 1.2 centimeters. Now how about this x or delta x? How much is this delta x? See, somewhere it will coincide. Okay, This is vernier scale and this is your main scale. Somewhere these both will coincide, right, at this point in this case. Okay, somewhere around not the first division, not the second division, but around the fourth division is coinciding. What does this mean? Okay, let's try and understand this point. Okay, so how many main scale divisions are there between this? Some 4 main scale divisions. Okay, and how many vernier scale divisions are there between this? Some 4 vernier scale division. Okay, if this was 0, this is going to be 5th. If it was like, if this is 0, if we call this to be 0, then this is going to be the 5th one. Okay, so let's say this is the 5th one. Okay, so there are 5 vernier scale divisions in this case. So 5 vernier scale divisions are there. And how about the main scale divisions? If you count main scale divisions, this is like this is the 0th one. Then there is like 1, 2, 3, 4 and 5. Okay, so it is going to be 1, 2, 3, 4 and 5. This 5th one is what of the main scale is coinciding with the 5th one of vernier scale division. Can I say that this delta x is nothing but the difference between those 5 vernier scale divisions and the 5 main scale division? Isn't it? So if 5th division is coinciding of the vernier scale, can we say that this 5th division is nothing but 5 main scale, this delta x is nothing but this delta x that you see over here is nothing but this 5 MSD minus 5 VSD, right? Can we write it something like this? 5 MSD minus VSD, 5 into whole of MSD. What is this? This is going to be 5 into least count. So what should have been your reading? Your reading should be this 1.2 centimeters plus of 5 into 1 least count. Okay, in this case your least count is going to be 0. So this is like 0.1, this can measure 0.1 centimeters and this can measure like 1/10. Let's assume in this case it's like 10 divisions coinciding with the 9 divisions. So that's going to be something like 0.09. So it's going to be 0.01 centimeter. And what was your measurement actually? Like this is the delta x. Delta x is 5 into 0.01 and that is 0.05 centimeters, right? Really simple. And what was this? This is 1.2. So total reading was this is what I'm going to call as main scale reading, and this is known as the delta x. So your reading is actually, your measurement is how much? Your measurement was main scale reading. So this is not MSD, this is reading. So yes, let's write it down as main scale reading plus of delta x. And how much was the delta x? Delta x was, this is 1.2 centimeters. You know that this is 0.1, 1.1, this is 1.2. Okay, and the 5th is coinciding, right? 5th of this and 5th of that is coinciding. Okay, but you're only worried about which division of the vernier scale is coinciding. You would have to literally count on the main scale division. Okay, so that is going to be 5 into 0.01. How much is it? 1.205 centimeters. That's how you measure, guys. Okay, this is the logic behind your measurement, right? They would often say just multiply it with the vernier scale division that is coinciding, but that is not the way to go about it. Okay, here the 5th division is coinciding. That means you have to multiply it with the least count and find out what is this delta x really. So we did typically that thing, right? So that is how you do it. So it's going to be, the measurement is nothing but, so this is only applicable. Let's understand what do I mean by this is only applicable. This is only applicable when we are talking about, you know, a case, a typical Vernier scale, where your number of Vernier scale divisions are going to coincide with a lesser number of main scale divisions. If at all, more number of, that is, if your Vernier scale readings that are going to coincide with your Vernier scale, main scale readings that are greater, then the scenario would completely change. Okay. So measurement is nothing but main scale reading plus least count into the coinciding Vernier scale reading. Okay, what do I mean by main scale reading? Main scale reading is just that point before, you know, this, in this case it is 4.3 centimeters, whereas in the earlier case it was 1.2 centimeters. That is going to be main scale reading. Okay, into the coinciding Vernier scale reading. In this case it is fifth, in that case also it was fifth. You multiply it with the least count, so you're basically calculating that small, you know, delta x. That's what you're doing, guys, right? Yes, of course they do. They ask, yeah, of course you're going to see so many questions, guys. So that is how you measure in this Vernier scale, this is how you read Vernier calipers. So let's work around this problem. So which is the division? What is the main scale reading? Main scale reading is 4.3 centimeters. Actually, tricky questions is what you would get. You not get a very direct question. 4.3 centimeters, because this comes in your experimental part. And here you see the fifth division is coinciding. Your least count is how much? Let's say 10 divisions was coinciding with the 9 divisions, so it's going to be 0.01 centimeters. Okay, that was 0.09, this is 0.1, so that's going to be 0.09 centimeters. And what is the Vernier scale division coinciding? Coinciding Vernier scale division is the fifth one, right? So what is your reading then? Your measurement or your result? Let's write it down as result. Result is nothing but 4.3 centimeters plus the coinciding Vernier division into least count. That is 5 into least count. How much is the least count? 0.1. So your reading is going to be 4.305 centimeters. Right? 4.35 centimeters. I'm sorry. Okay. 4.35 centimeters. Simple. Right? So that is all you have to do, guys. This is how you read a Vernier calipers. Let's have a look at few problems before we get into it. Just you have to remember, measurement is nothing but main scale reading plus of least count into coinciding Vernier scale reading. That is all you need to do. So let's get into a JEE advanced problem. So it's a very interesting problem, students. Okay. So they are measuring, the diameter of a cylinder and using a Vernier calipers with no zero error. So we'll come to the part of zero error. There is something known as zero error in your, in pretty much any measuring instrument. And it is found that, the zero of the Vernier scale lies between 5.1 and 5.15 of the main scale. Right? And the Vernier scale has 50 divisions. I think this was asked in 2015 or 2013, something like that. Okay, this is equivalent to 2.45 centimeters, right? And the 24th division exactly coincides. The 24th division of the Vernier scale exactly coincides with one of the main scale division. What is the diameter of the cylinder is what is being asked to you, right? Okay, so you need to first of all find out the least count. If you find out the least count, the answer is there. So what is the main scale reading in this case? So if your measurement lies between 5.10 centimeter and 5.15 centimeter, main scale reading is, what is that measurement until where you're confident about? 5.10 centimeters only, right? You need to find out what is that value of delta x, okay, that we just discussed. So we'll find out the value of delta x. Before that, we need to do something known as finding out the least count, because it has been told to us the 24 division is the thing that is coinciding. If you multiply this 24 division with the least count, you will get it. And how do you calculate the least count? So what is the value of 1 MSD, 1 main scale division? So it has an accuracy of 0.05 centimeters. Incrementing by 0.05 centimeters, else they would have told you it lies between 5.1 and 5.2, but they have told you it lies between 5.10 and 5.15. That means the least count, or sorry, the least possible value that you can measure with the main scale, or the value of 1 MSD is nothing but 0.05 centimeters. And how about your Vernier scale? They have already told you 50 divisions of the Vernier scale is equal to 2.45 centimeters. Okay, so you need to find out. So that means I'm going to take a different color for Vernier scale. Let's do that. So 50 Vernier scale divisions is equal to how much? 2.45 centimeters. That means how much is one Vernier scale division? It's 2.45 divided by 50. Okay, this is going to be 4 and 0.49. Okay, this is going to be 0.049. After like 50 by 50, it's 0.49, so it's going to be 0.049 centimeters. Right? So you got two results. We know the main scale reading, that is pretty obvious. It's going to be 5.10, not 5.15, guys. Okay, that's why we need to understand the concept. Okay, it's very important that you understand the concept throughout this chapter, especially for your JEE Advanced and JEE Mains, because it's a very, very conceptual and it's a very practical subject. Okay. So yes, your one Vernier scale division is 0.049 and your one main scale division is 0.05 centimeters. Let me just write it down, because this is an interesting question. Let's do it, step by step. But I think you already got the answer by now. 0.049 centimeters. And how much did we have the Vernier scale division as? Vernier scale division was something like one main scale division, one main scale division is 0.05 centimeters, right? And let's understand this part. Let's take a different color. So what's your least count? Least count is equal to 1 main scale division minus 1 Vernier scale division. How much is that? 0.05 minus 0.049. How much is that? Least count is nothing but 0.01. Okay, not even 1, 0.01 centimeters, right? It's 50 and you'd get it as 0.01 centimeters. And what is the 24 division? So now you know the answer, guys. It's very simple. And your reading, how much? Main scale reading plus least count into the coinciding division. In this case it is 24 division. Okay, and it's 5.1. We just discussed that it's going to be 5.10 actually. Okay, and 24 into 0.001. How much is the reading? Reading's value is somewhere around that is going to be 5.124 centimeters. Quite easy. Yes guys, it's easy. It's easy, cakewalk, and there you go, 4 marks. Right? Quite easy, right? You got it. So what did we do? we first of all found out what is the main scale reading. I told you it should be 5.1 centimeters, 5.10 centimeters, not 5.15. It lies between 5.15. You need to find out the delta x. That's what we found out. And what is the value of one main scale division? One main scale division. They haven't explicitly said what is the value of one main scale division, but they have told you it lies between 5.10 centimeter to 5.15 centimeter. That means one main scale division's reading is going to be 0.05 centimeter. Okay, and in the next case, they have already told you this thing explicitly. 50 divisions of the Vernier scale is equivalent to 2.45. So you basically say that 50 divisions of Vernier scale division is equal to 2.45. From there, you would find out the value of one Vernier scale division, which is going to be 0.049 centimeters. But this is not the least count. Okay, this is one Vernier scale division. What about your least count? For the least count, you are going to subtract one main scale division from one Vernier scale division. Okay, it is basically 0.05 minus 0.049. How much did you get it? 0.001 centimeters. And rest is just, quite easy. Right? This is MSR plus least count into the coinciding division. Coinciding division here was 24 division. You just did the same thing. Okay. Why are we only talking about Vernier scale divisions? Because there is the 24 division for main scale is probably lying somewhere, but it starts from 1 or 0 as it starts in Vernier calipers. While you're going to measure the delta x, we just discussed 1, 2, 3, 4, 5, how we went through that. Okay, that is it. It's a very simple question. So let's do another one. So given to you a side of a cube is measured by a Vernier calipers. This is simple, straightforward one, guys. Okay. So the side of the cube is measured by Vernier calipers. 10 divisions of the Vernier calipers coincides. Same, the very typical one. So you can even directly write down what is going to be the least count, etc., and find out everything. Okay, where one division of the main scale is 1 mm. Then what is the least count going to be? 0.1 mm. Is that what it is going to be? Yes, I guess so. Okay, and so how did I say it directly? We use it often in the lab, isn't it? It's a normal Vernier scale, right? The main scale division reads 10 mm and the first division of the Vernier scale coincides with the main scale. Pretty easy, right? The main scale reads 10 mm and the first one coincides with the main scale reading. The mass is given to you, you have to find out density. Density, you know how to find out mass by volume. So first of all, you need to find out volume of a cube. So first of all, you need to find out length of one side. Okay, exact length of one side. I mean, in this case, it's a Vernier caliper question, and that means we have to do typical math, and we would do that. Okay. So how much is one Vernier scale division? One Vernier scale division is nothing but 1/10 of the main scale division. Sorry, 9/10 of the main scale division. Okay, that's going to be 0.9 mm. Okay, how did I get it? 1 VST is equal to 9/10 into 1 mm. Okay, and what is the least count? Sorry, it's 0.01, guys. Okay, one main scale division minus one Vernier scale division. Do the math. Sometimes it's going to be helpful in these kind of questions. And you know what is the main scale division value? It's going to be only 1 mm. 1 minus of 0.9. How much is that? That is 0.1. Okay, sorry, it was only 0.1. Now what we need to do? We need to find out the length of the cube. And the length is quite easy in this case, right? Let's do the length. There isn't any space over here. Let's move on to the next page. I hope everyone understood the least count part. So what is being told to you? It is told that the first division of the Vernier scale coincides. Very easy. No multiplication, no complication, nothing. And 10 mm is what it reads on the main scale reading. So reading, or the length in this case, is nothing but main scale reading plus of least count into the coinciding one, that is 1 in this case. Okay, sorry, first division. Okay, and 10 plus of 0.1 mm into 1, so it's going to be only 10.1. mm is what given to you, and they have asked you to assess it in centimeter cube. Notice it. Per centimeter cube. So convert this 10.1 mm into centimeter. 10.1 mm is equal to 1.01 centimeter. Of course, you are not taking into account the significant figure. If you had been, it should have been 2.736. That is an issue in this question. But anyway, you can say it's 1.01 centimeter, right? And in terms of centimeter, you can assess it up to a second decimal place. Okay. So generally, we say that while you're converting from one to other, that is just a shear measurement. In this case, it's a very precise measurement. So you can say 1.01 centimeter. What is the density? Mass by volume. And they have asked you to, round it off to appropriate significant figures. So this is the least significant figure, 2 decimal places. Hi Bhanupriya, hi, how are you? So how do you do this? Now let's do this. So you're going to round it off to 2 significant figures, that's it. Right? Let's do it. So what is the mass? 2.736 grams divided by 1.01 whole cube. Okay, in this case it is cube, so mass by length cube is what we did, right? Now this is volume, right? So how much is this? This is 2.736 divided by 1 cube. You would get something like 2.655555, so gram per centimeter. You can work it out, and wave will finish mechanics, and then we will proceed with wave. So this is the nearest significant figure. You have to round it off to 2 significant figures since it was 1.01 centimeter, right? So you have to round it off to 2 significant figures. 2.6555. Anything 5 followed by any non-zero number, you're going to round it off as 2.66. Right? After that, we'll do optics, and then we'll do waves. Okay, your optics also carries a lot of weightage, guys. Okay. So there would be some places, where your Vernier scale reading is greater than your main scale reading. What do I mean by this? So what do I mean by here is, we said that, n into Vernier scale reading is greater than, okay, earlier we used to say this, okay. So it's basically 1 Vernier scale division is greater than 1 main scale division. Earlier we used to say this, I mean this is fine. This is like saying that n Vernier scale divisions is equal to m main scale division, right? And now if I had told you Vernier scale reading is greater than main scale reading, that means 1 Vernier scale division is greater than 1 main scale division. Until now we didn't ever face that case. right? Until now, we never ever faced that case. But you would can see a problem in your JEE Advanced. One Vernier scale reading VSD. Okay. So let's say now if one Vernier scale reading is greater than your one main scale reading, in that case you know M is greater than N. Earlier N was greater than M, now M is greater than N. How do you work around these kind of problems? Let's see how to do this. So that's the reason, guys. This is delta X. Okay. And what am I typically stating here is one value of one VSD or VSR, one Vernier scale reading is greater than one main scale reading. Until now, if you remember, we had like 0.9 centimeter on Vernier scale reading as one Vernier scale reading, and main scale reading was 0.1 like 0.09 centimeters as Vernier scale reading, and we had one main scale reading as 0.1 centimeter. Now if I told you one Vernier scale reading is greater than one main scale reading, how are you going to assess it? Same way, no difference is going to happen. So your measurement is not going to change. The way you used to measure did not change now. Even now you're going to assess this delta X. And let's do this. Okay, so your measurement is not going to change, guys. Okay, your measurement is going to be the same thing, your main scale reading plus of your not least count into coinciding division. Now how are we going to do? Let's say your 8th division, this is some 8th division on your Vernier scale, and this is from starting from here, this is like the bth division of your main scale. So what would be a reading be? A into Vernier scale reading, which should be subtracted from your main scale reading, which is going to be into main scale reading. Coinciding main scale division, understand that point. One main scale division is equal to the least possible value of, so this is going to be your addendum or the thing that you are going to add. Okay, I hope you understood this point. See, what is happening over here is you have the bth division starting the count from here. Okay, you have the bth division coinciding with the ath division of Vernier scale. Vernier scale anyway starts from 0. Here you will start counting it from 1. Okay, here you will start counting it from 1. And here you will start counting it from 1. If you start this as 0, then you will start this as 0. Okay, you're only worried about this delta X. Okay, how do you calculate this delta X? What you're going to do is you need to find out this small length, which is nothing but this length on your Vernier scale reading, sorry, your main scale reading, minus this length on your Vernier scale reading, which is going to be how much? B into your main scale divisions. What is that? That is this length. And what about the next one? It's going to be minus of A into your Vernier scale reading or Vernier scale division. Okay. Right, you understood this part. So now when am I talking about this part, which is that length? This length. And which is that B into MSD, this is this. Don't you think that minus this would give you the delta X? Yes. You got your measurement. Let's do a problem on this, a JEE advanced problem on this, then you get more clarity on this. So what you typically do is coinciding main scale division. That's going to be actually generally plus 1, plus 2, plus 4, you don't know. Okay. It's going to be some coinciding main scale division minus coinciding Vernier scale division. Main scale reading is typical. Okay, this point that lies before the 0 of your Vernier scale. Let's say Ath division is coinciding on the main scale and Bth division is coinciding on the Vernier scale. So you are going to write down A into 1 MSR, which is nothing but 1 main scale reading or 1 main scale division, minus of B into VSR, 1 main scale, 1 Vernier scale reading or 1 Vernier scale division. Pretty simple, guys. Think about a situation where each calibrated mark on your Vernier scale is greater than the reading that you have on your main scale. If this was 0.1 centimeter, this is possible, okay? If your 1 main scale division was 0.1 centimeter, if your Vernier scale division was 0.11 centimeter, this is the case that we are talking about. Right? You'll understand it, don't worry. Okay, let's move into a problem. So this is a JEE advanced problem. So I think this was like multiple correct answers and single correct answer, I guess. Okay. So there are 2 Vernier calipers, both of which have 1 centimeter divided into 10 equal divisions on the main scale. The Vernier scale of 1 calipers has 10 equal divisions that correspond to 9 main scale divisions. Weird, huh? Okay. And the Vernier scale of the other Vernier calipers has 10 equal divisions that correspond to 11 main scale reading divisions. This is the weirder one. Okay. This was actually a normal one. 9 main scale divisions coincide with the 10 Vernier scale divisions, whereas now in the case of C2 you have 11 mains. It's a very straightforward question, guys. So they have given you some picture like this. I'll zoom in this picture, don't worry. Actually the same kind of divisions will be coinciding in both, if you notice it. Okay, let's move on then. Let's understand how to do this. So C1 has 10 equal divisions that correspond to 9 main scale divisions. C2 has 10 equal divisions that correspond to 11 main scale divisions. So C2 is the case that we have just discussed. Okay. So now let's see how to do this. See, in both of this, if you have noticed, it is the second division after 5th that is going to coincide. So it's going to be the 7th reading on the Vernier scale. Okay. And how about this? If this is 0 and if I call this 7, this is going to be also something like 0. I'm going to call this 1. This is going to be 2. This is going to be 3. This is going to be 4. This is going to be 5. This is going to be 6. And this is going to be 7. And how about in this case? I'm going to call this 0. I'm going to call this 0. 0, 1. Let's count in C2 and see if we get something different. Okay. So again 7th. Don't worry about it. It's going to be only 7th. That was the entire thing about the question. Okay. You had to understand the concept of finding out, the small delta X. Case 1, it was very easy. Okay. This is 0. This is 1. This is 2, I'm writing down directly 3, and then this is 4, this is 5, this is 6, this is 7, this is 8, guys. This is 8 division. Okay. Whereas here 7 was matching with 7, here 8 was matching with 7. 8 divisions would be there, right? 8 divisions. If you notice, 1 division, 2 division, 3 division, 4 division, 5 division, 6 division, 7 division, 8 division. Here it will be only 7 division, you know that 7 division is coinciding. But notice over here 1 division, 2 division, 3 division, 4 division, 5 division, 6 division, 7 division. Right? Let's move on to this problem. How to do this? So as usual, you would do is like, you know, first of all, you know the main scale reading. Main scale reading is pretty simple. It is like, you know, this is like 2.5, 2.6, 2.7, 2.8 in both cases. That lies before 0. So in both of the cases, main scale reading is 2.8. I think this is given in centimeters. Let's just verify. Yeah, it does not matter. Okay, they haven't given. Okay, 2.8 centimeters. Okay, now this is simple. 9 and 10 divisions correspond to 9 divisions. The same kind of case that we have did. 7 division is coinciding. So what should be the reading? The reading should be, okay, let's do for C1. Okay, you know the 7th one is coinciding. Okay, so don't worry about it. The 7th one, if it's not visible, it's the 7th one. Okay, but in exam, the picture would have had this clarity. Make sure you are able to identify that you know the division that is coinciding. Okay, and in case of C1, you can do it in the typical way. What is the value of least count? That is 1 main scale division minus 1 Vernier scale division. 1 main scale division value 1 centimeter in both cases. Okay, 1 Vernier scale division is 0.9 centimeter. Understood? Awesome. 0.1 centimeter is 0.01 centimeter or 0.1 centimeter. 1 centimeter is divided into 10, so it's going to be 0.1 and this is going to be 0.09. Just a moment. That is it. That's, if you understood this concept, you understood. If you understood this problem, you understood that concept. That's it. Okay. So this is 0.01 centimeter because your main scale was divided into 10. 0.01 centimeter. Oh, sorry, 0.1 centimeter. I'm really sorry, guys. This should be 0.1 centimeter. And how about this? This is 10.9, the usual case. So 0.09 centimeter. So your least count is nothing but 0.01 centimeter. In C1, you can typically do it this way, and you have the main scale reading, which is nothing but 2.8, I guess. Okay, and 7th division is coinciding. That is the 7th one, right? So what is your reading then? Your reading is simple in the case of C1. C2 is different. Notice it, students, notice it. Okay, in case of C2, find out 1 Vernier scale division. Yeah, 2.8 is fine. 2.8 is fine. Yes. Reading is equal to 1 main scale reading. Sorry, main scale reading is going to be 2.8, and your Vernier scale reading is going to be your least count into Vernier scale, coinciding Vernier scale division is 7. So into least count, that is going to be 2.87. Okay. 2.8 plus 7 into 0.1, that is going to be 0.01, sorry, that is going to be 2.87. Okay, C1. Now let's do the C2. C2, 8 minus 7 is what it is, right? C2, just a moment, I'm just going back. Let's erase everything and just focus on just C2. C2, if you remember, what was this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, and it is coinciding at the 7th one. It is 8. How about this? I'm writing it down with a different color. Try to understand this part. I'm just repeating it again. 1, 2, 3, 4, 5, 6, 7. So if the small part was delta x, how much is delta x? Talking about C2. Delta x is how much, students? It is, okay, 8 MSD minus 7 VSD. Is that correct? 8 MSD minus 7 VSD is what delta x is. You could have done it, just multiplied it like with a given expression, but objective is try to understand it. What if it was like 20 divisions on Vernier scale and 16 divisions on main scale? Something like 16 divisions on main scale and 20 divisions. But the concept is straightforward. You have to count the number of divisions. Here it is 10 equal divisions, so don't worry about it. There, like if it is not 10 equal divisions, you're going to count. You're going to count, guys. Literally. Finger counting or whatever you call it, hand counting, etc. Alright. So let's do it for this case of C2, but before that we need to find out something. That is the value of one Vernier scale division. And what it is, they told you 11 main scale division, 11 main scale division correspond to 10 equal divisions on Vernier scale. You can read the detailed question. I just shortened it down. So it's going to be 11 by 10 main scale division, 1.1 main scale division. Let's for now just keep it as 1.1 main scale division because it will become easier. What is the value of one main scale division? We just derived it. Same main scale divisions, guys. 0.1 centimeter. 1 centimeter is divided into 10 divisions. Okay. And what is the value of delta x? So until now we are only doing delta x. We weren't doing anything different, guys. Even now we are doing the delta x. Even earlier when we are doing the coinciding division into least count, that was also delta x only. We are finding out this delta x. Right? How much is this? 8 main scale division minus 7 Vernier scale division. Right? 8 main scale division. 8 main scale divisions minus this 7 Vernier scale division. Just emphasizing again and again so that you don't make the mistake, students. Notice this. This is a specific case of, or you can call this as a special case of your, like your Vernier calipers. Right? 8 main scale division minus of 7.7 main scale division. How did I get this from over here? Substituted it. How much is that? 0.3 main scale division. What should be a reading in the case of C2? That should be, and how much is this? 0.03 centimeters. Is that what it is? 0.3 into MSD, which is nothing but MSD is 0.1 centimeters. 0.3 into 0.03 0.3 into 0.1 is going to be 0.03 centimeters. And what was your, so they would have interchanged it as well. So notice that thing. That is also something that you need to notice. And what is MSR? MSR was 2.8, I guess. 2.8 plus 0.3. How much does that give you? 2.83. Simple, pretty simple, pretty simple. It's conceptual. And no, they haven't even interchanged it. Okay, they haven't interchanged it. Did you notice something unique in this? Since it is 10 division based thing, it is kind of complementing. Okay, I hope you understood this concept. You can watch it again maybe after the class. So let's get into something interesting known as your zero error. Okay, so your Vernier calipers can come with zero error, your screw gauge can come with zero error, your many instruments can come with zero error. So zero error is when in this case you say that zero of your Vernier calipers, like in this case in the simulation you see over here, right? Your zero is not coinciding. Zero of the Vernier scale is not coinciding with the zero of the main scale, then you call it zero error. So it depends, there are like different kind of zero error. What is a zero error? Zero is a systematic error. Okay, it comes under the category of systematic errors, and generally zero error tends to move either you are reading to the left direction or to the right direction. You'll understand that either it will add a negative sign or a positive sign to the final reading. So when zero error of the Vernier calipers, when the zero of the Vernier scale and the zero of the main scale does not coincide, that is known as zero error. Okay, it arises an issue in your reading, and you can adjust it. Okay, it's a common issue that you would observe in many of your Vernier calipers. In your lab, if you can notice the simulation over here, your Vernier caliper zero is moving on the other side. Just just notice that we are actually subtracting it. See, your zero is not coinciding with the zero. Okay, your zero is not really coinciding with the zero. Okay, then when I'm keeping this this little piece of rod or some object over here, then while adding I'm subtracting the 0.1 centimeter, because it depends. In this case it's 0.1. Let's understand what am I talking about. Okay, so there are two kinds of zero error when you're talking about zero errors. One is going to be negative zero error, the other one is going to be positive zero error, and the case that we saw earlier was negative zero error. Okay, and there would also be a positive zero error. Then the zero of the Vernier calipers, let's say this is the Vernier scale, and when I'm saying that the zero of the Vernier scale lies to the left of the zero of the main scale, then it is known as negative zero error. Notice it, zero is over here, this is main scale, this is over here. Okay, so if you can notice this, good, awesome. So this is your Vernier, this is your main scale, and this is your Vernier scale, this little one. So what does it tell you? It tells you that some amount of this delta x is left. Again, it's about delta x concept, actually don't worry about it. So some amount of delta x is something that you have to add to your reading. Sorry, that was then positive zero error. I don't know, the simulation went wrong, I guess. So whenever you are measuring some delta x lesser. Okay, whenever you're measuring some delta x lesser. So let's say 7th division is coinciding, right? So you know that least count into 7th division is this delta x, right? So let's say 7th division is coinciding. You can see over here the 7th division is coinciding, and your Vernier scale is to the left. It lies left outside of that main scale. So you need to find out this delta x, the small distance that you have to always add to your reading. You have to add in cases of negative zero error. How much is this delta x? There is nothing but least count into 7th in this case, coinciding division, 7 LC. That is it. That is about, you need to add the negative zero error, not subtract but add. So this is like you're actually always reading lesser and lesser. Okay, so you have to multiply least count into the coinciding Vernier scale division, and you would add it. You cannot subtract. Okay. So there can be the other kind of zero error where you're always reading more than what you should be reading. That is going to be known as positive zero error. Forget this heading, guys. Forget this heading, and you need to assess this delta x. The same thing is what we are going to say. If at all in this case 6th division is coinciding, this is the 6th division coinciding. I'm going to say this delta x is nothing but least count into the 6th division. So in this case, delta x was, you need to always subtract that 6 LCM in positive 0 error. And positive 0 error, rise to the right. Okay, again this is also wrong. It has to be subtracted from your reading. Negative 0 error, you would add because you're always measuring little lesser than what you should be measuring. Positive 0 error, you would subtract. Right? You're always reading much more than what you should be reading. Okay, this is due to some instrumental defect. This is a systematic error. Okay, so don't worry about it. So that's it, students. Do share the video and make sure you are liking this video, sharing this video. You talk about JEE English channel. It's a free of cost initiative by Unacademy where we are delivering quality lectures from basics until your depth for your JEE preparation. So make sure you're sharing this video. Kill your ego, guys. Make sure you're understanding everything. It's not important to have any ego. If you have any ego, then it's going to become really tough. And that being said, avoid gossips, work hard for your success, and also work smart for your success. Acquire knowledge, but also share it, because keeping knowledge does not actually help you progress, because it's not really going to help you learn more. You're not going to brainstorm things. So keep sharing it. And students, if you're already on Telegram app, check out this link on the description box below. You need to just, all you need to do is click onto that link and you will get onto a channel. Else, if you already have Telegram app and you're right now on the search bar, just type in JEE_English. You will find us. This is the one-stop place where you get all the updates happening on our channel, that is JEE English channel, be it on YouTube or the lectures are conducting any lectures on like Unacademy Learning app. You'd get all the updates on time and also beforehand, guys, so you can be ready for it. For an example, live YouTube sessions, strategy sessions, etc., special Sundays, special Fridays, you get all the updates in this one place. So it's like the one-stop place where you would get all updates happening on JEE English or that are being conducted by the lecturers of JEE English. And that being said, you can also check out my previous lectures on Unacademy Learning app. This is a lecture on color coding of resistor, and there was anywhere around 5 questions combined in your JEE Mains 2019. It's a very, very easy topic, less than an hour topic. You can fast forward it and learn it, and you can check out Unacademy Learning app to attend this lecture. It's going to be very easy, so make sure you attend it. We also completed electrical instrumentation in one shot. Do also complete the lecture, especially JEE Advanced aspirants. Complete electrical instrumentation. Maybe color coding is not very relevant. I don't think color coding is there in your JEE Advanced syllabus, but maybe you want to cover this. It only takes hardly 1 hour, but you do definitely have electrical instrumentation that was conducted on 1st of September. Do cover it, guys. Don't miss it out. And to attend many such awesome free of cost special classes, all you need to do is download an Unacademy Learning app by typing in Unacademy on your Google Play Store and App Store, and the first result is going to be an Unacademy Learning app. All you have to do is click on that install button, and there you go, guys. You will have the app on your mobile phone, and you can now attend classes from anywhere, and you will also get live and timely updates using the Unacademy Learning app. And students with Plus subscription, do download the Unacademy Learning app so that you can attend classes from anywhere, and if not, also please do attend the classes from anywhere. And that being said, guys, if you're looking for an awesome platform for your test preparation, a complete package where you can assess yourselves, and not only that, it comes with personalized insights, but it's the best in class education tool that you have for your JEE preparation. And guys, what am I talking about? I'm talking about a paid subscription that comes with everything that you need for your JEE preparation, be it your test series, be it your live quizzes, be it a structured program where you have to attend quizzes twice a week and attend the test series every week. And if you're serious about IIT JEE, this is the place, guys, and this is the thing that you need to purchase. And we have the best educators across the nation on this single platform, and also popular authors like DC Pandey sir on this single platform. So make sure you're downloading this Unacademy Learning app, and maybe you can avail the subscription right now. And you have many perks and benefits of having the subscription. It's only single subscription, and you get unlimited access for that time period, and we have anywhere around 6,000 plus materials for your JEE preparation and 1,500 plus active courseworks for just your JEE preparation, guys. So you can imagine the kind of content we have. All you need to do is click on that extension bar, choose this plus, choose your goal as IIT JEE, and avail the subscription. That's it, students. That's all you need to do. And guys, let me tell you something. The prices are going to hike from tomorrow. That is within maybe next 24 hours or 3 hours. So make sure you are availing this subscription within this day, so that you don't want to miss it out, guys. Enroll soon, don't miss it out, especially 11th class students. Don't miss it out. You are going to pay more than 50% of what you'll be paying right now. So you can check out our subscription right now. You can apply Murli live coupon and get the best price on it. That's going to be 32,400, which is pretty economical, guys, which is pretty economical, for the kind of value that you get, for the kind of things that you get on this platform. And students, after tomorrow, I think, or from tomorrow, it's going to be 50,400, even if you apply Murli live coupon. So make sure you're applying the coupon, and make sure you purchase it today, so that you can save 18,000 on your purchase, right? And that being said, how do you avail it? All you need to do is choose your subscription as 24-month subscription, especially if you are in 11th class or 10th class or 9th class. And make sure you're applying Murli live coupon to get the 10% instant discount. This would be the best price that you can avail right now, so avail it as soon as possible. And if you're a long-term or dropout, still move on early, guys, so that you don't want to miss it out. Right now the subscription prices are low, so get it soon and you can get a 10% instant discount on it. Hurry up, students. Make sure you're applying the coupon, and it's it's going to be like a little bit more expensive. Make sure you're getting it early, guys. Stay safe. See you in the next class. Take care, and make sure you are understanding every single thing that we have discussed today. We discussed about least count, we discussed about Vernier scale reading, we discussed about how to read on a Vernier calipers, what is a zero error, what is a negative zero error, what is a positive zero error. Not only that, we also discussed in something interesting known as where your one main scale division value of the one main scale division is lesser than your one Vernier scale division. Make sure you cover everything. I hope it was a short lecture on your Vernier calipers with all the problems that you required on it. We'll do more on the DPPs, but make sure you cover everything, guys. Everything means everything on this topic. Every 2 or 3 years you get one question, at least one question from this, be it in JEE Mains or JEE Advanced. So cover it and make sure you are doing everything that is required for your JEE Mains preparation. See you in the next class. Take care. Stay safe. Bye bye.